My name is Paul Warren.
I'm Heather Riddle.
We are some software engineers from Healthcare Service Corporation. We're going to be talking today about Apache Geode, how we move data into Apache Geode from existing databases with lots and lots of data.
We just want to give a quick shout out to a couple people who really helped us with this. We have Anu, she's another employee over at HCSC, and we have Jeff from Pivotal. The two of them really worked hard. They were instrumental in getting this type of process in place for our production systems. And they also gave this talk earlier in the year and told the story of how we got where we are. So big thanks to them for all the help.
They're also in this room, so they're going to keep us honest. So if you want to chat with them too afterwards, they'll be around. So let's talk about Healthcare Service Corporation, who we are. So we are the largest customer-owned health insurance company in the United States, and the fourth largest overall. We operate in 5 states as Blue Cross Blue Shield. It's Illinois, Montana, New Mexico, Oklahoma, and Texas. We are 15 million members strong, and that's supported by 2,100 IT employees. So if you ask any of those employees, any employee in the company, you'll see that we are very purpose-driven. We are customer-owned. We don't have a board. We do have a board, but different talk. And our mission is to stand with our members in sickness and in health.
So let's talk a little bit about the problem we were facing. We have 15 million members, and they all want to get their information from our websites, our apps, our customer service portals. They want it to be consistent across all of those platforms, and they want to be able to get it fast. And it's not just our members, it's hospitals, it's providers. Anybody that needs information from us, they expect us to be able to deliver it. And the problem is that our legacy systems that were in place just kind of weren't cutting it. They were inconsistent. Data wasn't always the same across these systems, and it was really hard to integrate with, and they were just really very slow. So we learned that with Apache Geode, we would be able to store the data in an in-memory data grid, and we would be able to make sure that our consumers could get their information really quickly. So then the problem occurred, like, how do we get all of this data into Geode? So we have millions and millions of records, and we need to get it into this system that's going to enable us to help our customers. How do we do that? We have membership systems, claim systems, benefit systems, and across many different sources as well. We process 1 million claims per day. That's a lot of data. So how do we move data at this scale from so many places into Geode, and how do we continue to keep our data always consistent with the source applications doing updates all the time? So this is where simple extract, transform, load, or ETL comes in. We have this really basic diagram up here where we have a source database and we need to get that data into the target. So one of the ways you can do that, typical ETL, is going to be a file extract of that source system. It's going to run through this ETL box, and then it's going to be written into your target database, whatever that is. This typically is going to run in batch because it's a file. It's really difficult to start writing your business rules in this ETL box because you can use different tools, like there's drag and drop mechanisms where you basically say value A becomes value B in the target system, and that's just really hard to scale as your data becomes very complex. So there's problems here. We recognize that. It's not scalable. You can't really parallelize this easily, and it's not real time, so data becomes stale. We're running as batch, so this can definitely get better. So by creating an event-driven process, we were able to achieve near real-time data transfer.
So this is great. So as data changes in our source database, we can go ahead and create events that tell us about that data. So this gets us a little bit better, right? We're able to get triggers on our ETL process. We're able to, as these data changes, get them into Geode. It's not this batch process that maybe runs once a day or once an hour. We're getting better, right? We get a little bit closer. So that ETL process there, that event table there will hold that information that tells us about that change. So some IDs about the data that changed. Was it an add, an insert, a delete, some other metadata about it that can help us understand what changed and how we need to process that when we go down the stream to put it into Geode. So this is better, right? But it's not great. There's other problems. It mostly comes into problems of scale. We still have like that monolith concept here. We can see it's just one service. It's listening to for these changes. And it's not going to be scalable. We're not going to be able to horizontally scale them out. If we do, then we're going to be, if we try and run this like 2 of these instances next to each other in parallel, we're going to be probably picking up the same events. They're going to be fighting for reads on that event table. It's not going to work. We can try and multi-thread that black box. We can get a little bit better, but we're still in that same JVM. Even if we go to 200 threads, we're still not going to get that throughput we need when we're talking about millions and millions of updates and changes and information like that. So we can make this a little bit better, right? And we make it a little bit better by restructuring that monolith into that microservice architecture design.
So we looked at what bottlenecks we were seeing in a system like that, and we found that it was the pieces that were doing a lot of I/O work. So as you saw, our event reader becomes like a listener in this diagram, and that's doing the I/O between our system and the event table. And the other thing we saw was the load was the other I/O piece that was very slow. So basically what we did was we split out the event reading piece into a listener microservice with one responsibility, and that was to read events off of the event table and push it out to another microservice. So it had one job. And then that microservice was in charge of extracting that data using the keys from the event metadata, extracting that data from the source database, wrapping it up in some like nice little payload and transforming it into what the load piece was expecting. So then load's responsibility is just to take that, unwrap it, and throw it into the target database. So everything had its own little responsibility and was split out, and now it's scalable. So we can take the extract transform piece, parallelize it, and it can start sharing in the workload. So the throughput we needed was achievable because we were able to scale the pieces that were necessary to scale. So we've gained a lot of flexibility in breaking up that monolith into these just 3 concepts. Messages need to be passed between each component, though, which is hard. And we're responsible for like a lot of boilerplate code and configurations just to get listener to talk to the processing piece to talk to the loading piece. So that was a pain point that we saw here. So we introduced Spring Cloud Stream to manage the message-driven communication between our components.
So we do a quick intro to Spring Cloud Stream here. It's a framework for really building this message-driven architecture, which really solves our problem really well. It abstracts all that boilerplate code that we just talked about. How do we manage the queues? Where do we connect to? What reads from what? And it abstracts that away in a very simple way. We just give it that base configuration. Go read from here. I want to use this as my message middleware, and that's where I want my data to go. So we see these 3 like core binding interfaces here: the source, the processor, the sink. They're very simple. Sources are the piece of your stream that really start the stream off. So we want to like create messages into our flow. That's the idea of the source. It only has an output. We think of a processor, and that's just something that wants to do work. I take an input, I can transform it, I can extract from it, but then I rewrite it into an output queue. So it has an input and an output. The cool thing about the processor is we can chain these up. So we can have, in this diagram we have 1, we can have 30, right? All of doing very small pieces, very small transformations, very easy and very simple to manage and upgrade. And then finally the sink is the end of the stream. How do we take this data in? What are we doing with it? Are we saving it to a database? Are we putting it in Geode, for example? It ends that flow. So we redraw our diagram with these concepts in mind, with the source, processor, and sink. And they lined up perfect for our use case, right? That source was reading this event table, creating these events, and pounding them into our stream. The processor then became that transformation level. We were able to parallel the workout. We were able to do all that transformation, the gradient from the database, from the information from the database, and worked really well. And the sink wrote right into Geode. And we didn't have to worry about the complexity of managing the middleware. Are we using Rabbit? Are we using Kafka? Are we using anything else we can think of? It just made it so much simpler. So let's jump into a demo. Let's see, we have some code. We wrote some code for you today. We want to walk through how it works. So if you're watching this online, we have the code up on GitHub. You're welcome to come with us if you'd like to do this along with us. We'll be starting at running the demo section in our README file. It has all the information you need on getting PCF dev off the ground, getting Apache Geode running on your local, all great things. That's what we'll start here.
All right, so we started off.
I can't see it on the screen.
Oh, how do I do that?
Exit presentation mode.
you see this now?
Yeah.
Okay, so we start off with some apps already deployed. I don't think you guys want to sit here and watch us do CF push and wait for the app to load. So we have the 3 components we talked about. We have a source app, we have a processor app, and a sync app. And we also have some services set up. So we've set up RabbitMQ, and I don't know if I get to the management. And that basically just auto-creates these queues for you by binding them to these services. So Spring Cloud Stream, just telling it what your inputs and outputs are, will create this kind of console for you in RabbitMQ. So this is already set up. And we've also got our MySQL instance up and bound to the appropriate apps. And I can show you here. We've already created some tables. So we have customer, customer order, item, and order item. And those are just traditional relational databases with lookup tables and whatnot. But then we have this DB events table, which is kind of interesting. So you have source key, which is a column that is going to identify the record that has some action performed on it. So it's going to just be either a composite key or a primary key, whatever's in your table. And then source group allows you to use one event table for many other tables. So instead of creating a customer event table, an item event table, you can use this source group to identify which type of record had an action performed on it. So you'll see some of our records have the word customer or the word item to say that this key belongs to a customer, so we need to go to the customer table to look it up. And then we have an action code, which is going to be I for insert, U for update, D for delete, just what type of action to perform. And a status code, which is going to start at 0, and that just means unprocessed. So we'll be able to update that as we move through the stream and perform actions on the event table. Okay, let me get out of this. All right, so we also have our regions created in GFish. So are we connected? Let's just do list regions. We have a customer region, a customer order, and an item region. Let me jump back into some of these steps here. Go ahead, Paul.
Yeah, so right now all those regions are empty, right? We have these databases. There's nothing really in them yet. So let's start with let's put us in a state that we were actually in when we first went to production. We have all this data. It's already in our database. So we go ahead and run these queries, and we can see that now we have some customers. They're in our database. It's very simple. There's only a few orders in this case. In reality, we're talking about 15 million members. We're talking about all their claims, their benefit information, like lots of data. So how do we get this initial start? Right? We have this data. We're in this great thing. We have tons of data, but nothing in Geode. How do we get started? So what we did was we said, instead of building a whole new process, instead of trying to figure out how do we actually create this one-time running program, we just said, let's create some synthetic events, right? This whole process stream is event-driven. What we can do is use that database event table and just manually insert. So what we actually have is an application that will go through those tables, find those keys of those members and of the information and of the customer here, and drop it right into that event table. So it gives us that information. It gives us the key, so you can see here order 1, customer 2, really original keys. We have the source group here. So that's kind of telling us what kind of data are we expected to be loading. Customer information is going to be very different than an order. So we want to make sure that we are transforming it the right way, and that's how we teach, that's how we pass that information along. You can see U, we're dropping a U saying that we have an update. Updates and inserts are pretty much mostly handled the same way. And then that 0 is us saying brand new data, it has not been processed yet. Let's make sure that source picks it up. So you can see here, when Heather ran this, it's actually really interesting. That first one got picked up by the time we got to the bottom line, which was the select. So if we rerun the select, you'll see they all switch from a 1 to a 0. From a 0 to a 1. And they've all been processed by the stream. So if we flip back to our Geode install, we can run some queries there, and we have them defined right here. And we can see that there's data here. We can see that there are customers, there are orders, there are items on those orders. It just came right through, super easy. So great, we have data in Geode. We can use it, our microservices can return information, and everyone's happy. But what happens when someone changes their order? What happens when someone needs more information? What if we need to make updates? So for this demo, we figured we can just create some simple triggers. We solved this problem a little different in our production environment, mostly because we didn't want to have an impact on the existing legacy apps that are already using this database. But for this demo, we have these triggers. So what we're looking at here is anytime that there's a change on these tables, so we have an insert, an update, a delete, we're going to go ahead and write this information to that event table. We're going to grab the ID if it's an insert, We're going to let it know it's a customer. It's an I for insert, and it's unprocessed. Updates are pretty close. It's just a U. Delete is a D. And that's so that any changes we're making to these, and then we have these for all those tables that we showed you there. So if we run this file, we created all these triggers, and there's not really any output, right? We just create triggers. So why don't we go change some data? Let's change some data, and let's show that as we change it in the table that actually holds it, it actually gets passed into Geode. So for example here, let's delete item 1 from order 1. So let's delete the pen from order 1 item. And you can see there the first line, order 1, just has paper on it. We were able to easily remove that. Let's try something a little more. Let's delete an entire order. So we want to remove this customer order. They cancel their order, whatever it may be. Run it again. Now we just have 2. So it's working great. What if we want to add a new item for sale? We want to sell a red swing line stapler, for example. So we go ahead and run this. Do we see it in our items table? We do. Second from the bottom. Perfect. And let's say someone wants to buy it. So they, real quick, put it online. They made the purchase immediately. We can make the change into our order, the order process system, the web UI, whatever it might be. And we can see it's the order number 4 right there on the bottom. Let's talk about how we made this work, right? So if we flip back to our code, that's not code. There we go. Let's start with our source. That's the thing that kind of kicks off the world for us. So if we go to our source, it's actually amazingly simple. And it still boggles me. So our source, and I'm going to make this a little bit wider so you guys can see the structure, is really a Spring Boot application and a YAML config. That's all we needed. So in our Spring application here, we can say that we're going to do this JDBC source configuration, and this is out-of-the-box functionality that came with Spring Cloud Stream, and we're telling it that we want to configure this from a relational database. We'll give you the information you need, but this is just telling you that this is a configuration you can expect to use. So let's look at that config. If we look at our application YAML, you can see that it's a couple queries, and where do we put the data? So right there, that query is just looking at that event table, and it's pulling that metadata out. Things like the event code, the key that changed, all that information that we really need to process that. And what's important to call out here is we're looking for statuses that are 0. Just give me the things that have not been processed yet. The great feature here, too, is as soon as we make these selects, these queries, we can run this update query right off the bat and flip that from a 0 to a 1. That's so that as this thing is constantly polling, we're not picking up the same message over and over and over and putting additional load through our pipeline or anything like that. There's some configuration, max rows. Maybe we can't handle 5, 10,000 at once. We need to do it a little bit smaller, but we're able to do it in a batch grab. And then finally, down here, this is where we're telling Spring Cloud Stream where we want to put that data after we grab it. So what happens is this picks it up, gives us the data as a map, a simple map, the key being the database column and then the value, and then puts it on this destination queue. So that's where our processor is listening. So if we flip over to the processor config, let's get a better understanding of how that works. I'm going to close some of this stuff too. So processor. So let's go ahead and start right into our processor configuration we have here. So if we look here, we can see that we have some wonderful auto-wired things. The important one is the subscribable channel. So that's that channel we're listening on to get data in. So we're subscribing to it. We also have this output. That's where we put the data to when we're done doing our transformation or business rules, whatever it might be. From here, we have some custom SQL that we can talk about when we get down to it. But let's look at the flow. So like we said, very simple. We're reading from this input channel. We want to then run it through our JDBC event message handler and then write it to this output. So that JDBC event message handler takes in all that information, looks at that source group, and figures out, what am I trying to process here? Is it a customer? Is it an order? Is it a new item? How do I transform this? So it looks at that information, and then from there, it's going to pick one of these DAOs that we've created, a customer DAO, an item DAO, or an order DAO. So these DAOs are straightforward. They have a data source, they have an extractor, and then they have this order SQL. So let's take a step back. Let's take a look at our application YAML and how we configured this, and then we can drive into what a course customer order result set extractor actually does. So if we go back to, oops, I made a change here. A couple of those. Okay, cool. If we go back to our application YAML, in our processor now, you can see that it's got these very basic queries, right? Select star from customer, select star from item, select star from or customer order. That one's actually the interesting one because it actually joins. So in a relational database, we have an item table, an order item table, a list of items that are related to an order, and then the order, which is going to have metadata like, what's the shipping address? Where do I want to send this to? When we put this in a Geode, we don't want to like just pick it up and put it over in the same format. We want to like aggregate this into really what that domain concept is. So we're really going to combine this into what an order truly is. An order is a customer, an address, and a list of items. So we're doing that here in a very simple way. We're doing that join. We're grabbing these two tables and bringing them together and bringing them in. You can see our Spring Cloud Stream config down there. What are we reading from? What's our input? And then what's our output? So here we can see we want to read from the event table. And then when we're done, we're going to write to this event result table. And that's the fun part from that. So let's go back to that processor configuration, and let's actually look at what that customer order result set extractor is actually doing. Ooh, come on, let's go a little bit faster. All right. So you can see here it's pretty straightforward. You can thank Jeff for this code. We're going to go ahead and go through that query. So that event handler that we have just runs the query that it was given, gives the information to the result extractor, and then we'll pass it down to the next step of the stream. So here we're going to run that query. We're going to go ahead and build that result, right? And in this case, it's a customer order payload. We're going to pull that information, ID, customer ID, address, timestamp when they order it. And then we're also going to aggregate items into it. So we have that full domain object of what an item, what an order really is. And from there, we're going to return it, and then Spring will do the rest and put it on the next step of the queue. So what's listening? Our sync's listening, right? The sync is now our end of our stream, and it's specific to Geode, right? How do we take this data that's now transformed, it's now in my model, how do I put it in a Geode? So when we go ahead and look at the sync, the majority of the configuration is around things like where is Geode, what's the port we want to connect to, what's the IP address of it, things like that. You can see here we also have this aggregator, we'll talk about that. But we still have a subscribable channel, we're still listening to events on a particular queue. And let's jump into our integration flow again, our sync flow here. So once again, we start from the input. We're listening to events in this input. We can run it through this aggregator thing. And then after that, we'll put it into our Geode message handler. So this aggregator, what it does is, as these messages are getting dropped, they're being picked up really fast. And we found that if we try and take one at a time and put it in a Geode, it's a little slow. So we can kind of leverage this a little bit and say, we actually want to chain them up. I don't want to do a put in a Geode every one at a time. I want to do maybe 500 at a time. 1,000 at a time, 5,000 at a time, right? Because this thing is really fast. It's moving really quick, and we don't want to spend time on just one message. We want to bulk load them. So what this aggregator consumer does, it allows us, and if we scroll down here, we can see the configuration for it. We can define how often we want to do that. So in this case, we have a timeout, how often we want to do this. In this case, too, we're saying send partial result. So like, we might say, I want to do a batch put of 500, but you don't want to sit around waiting for, if you're at 499, you don't want to wait for that 500th message. So we can also say, let's do it more often, let's do it at a time, let's do it at time, let's do it on count, let's do it in different ways. So that just kind of brings them together, and then we'll put them all to our Geode message handler. So if we look at that, right here, you can see it's pretty straightforward. It gets a set of these wrappers. Go ahead and grab that source group. What region am I putting it in, right? Am I putting, I don't want to put customers in items, that's going to give me trouble. So it figures out which one we want from there, gets that region name, and then really easily does this put on. Get the data, put it all. If it's a delete, it's a little different, right? We're not doing a put, we're going to do a remove all. But the interface is super easy with Geode, just a simple map idea, and we were able to remove it all from there. So that was how our code is able to get this data from the beginning all the way to the end in a very step-by-step, simple, methodical process that allows us to really allow this thing to, we could add business rules anywhere, we can scale this as we needed, and it's been working really well for us. So let's flip back to the slides. And I'm checking with Heather to make sure I didn't miss anything. You're good. Cool, so we're here. Cool.
All right, so Spring Cloud Stream, as demonstrated, allowed us to simplify our data flow without having to change the way we think about each of those core components. So we didn't have to change the way we thought about reading from an event table. We didn't have to change the way we thought about writing to Geode. We were just able to kind of plug Spring Cloud Stream in and accomplish that. It handled the communication between the services, so we didn't have to write any boilerplate code. We write some queries, some quick properties that bind us to the appropriate things, and we were pretty much up and running. But what happens when we have more than one data source? So we obviously don't have only one thing that we need to read data from. So this is kind of a picture of a way to add that second stream into a processor. So in this example, we used a file source, and that can be something maybe you get daily, hourly, maybe it's not real time, maybe it is. You get this file, and you're going to write some code in this app that's going to read that data. And it's going to dump it into a queue and pick up a new processor. So this is a processor that's written specifically for this source. And this processor is going to make sure that the data conforms to whatever your enterprise model is or whatever your opinionated idea of this thing in that data store or that file or whatever your source is. And then it's going to drop it into another queue. And this next processor here is going to expect that whatever it's getting is that same model. So those two processors on top of each other are responsible for outputting the same type of thing. And then this processor can apply business rules if that's what you want to do here. And you can add more, as we said. This allows you to add any number of sources, processors, and sinks. So that's kind of the idea of this flow. And you could add any number of these. So this is really all component-based still. Services are providing their own value for each thing. Yeah, if there are any changes or if any of the source systems can provide real-time data, it's just a simple change to this model here, and you're golden. You can keep going.
So let's talk about like failed messages, right? Like we have this idea that this data is flowing through, our APIs are reading from this geode, it's super fast, we're loving it. But what happens if we drop a message? What happens if we drop that super piece of information that that person needs to see? What if we dropped your order, right? You'd be really upset if you couldn't see it. So there's some great features out of the box that Spring has. At any point in time, if anything is failing, we can tell Spring to go ahead and drop the message right into this dead letter queue. So what we did was, it was super easy feature. It was flip the switch to true. It bound a queue, created it for us. I think you saw them in the first slide with Rabbit. And it'll just, an exception occurs, something bad happens. And this could be for any reason. It could be network flakes trying to get to the database. It could be poor logic. It could be poor data, right? Whatever those problems might be, it'll just drop it in that dead letter queue. So we kind of looked at those messages that were getting dropped there, and we're saying, wow, if we just rerun these, they'll probably work. So we just moved them from that status 2 back to that status 0, right, unprocessed. The event stream picks it right back up. So we said, let's write a sink on this. Let's write a sink that listens to this queue. It'll take that information in, it'll find that ID that was changed, go back to the event table, and just flip it back to a 0. Let's try it again. Most of the time that works. The rest of the time, we just tried to process a message forever. So that's what we added this attempt column. Let's say, let's try maybe 3 times. So we made that quick change, super easy. That sync is the only thing we had to change. So what if we're at that 3 already? We just flip it to like a 3, right? Unprocessed. This way someone from operations can dive in and actually see what's going on with that data or with the logic, whatever the problem might be. But we don't want to spend all of our time, sorry operations, go find out what's wrong. So you're able to save a lot of headache and a lot of pain right here. Cool.
Yeah, so this is kind of a picture of a small portion of what like your end-to-end system could look like. This is really similar to the failed messages diagram before. We've added the CDC box though, and that is that's there because we don't want to touch that legacy database. Like we don't want to add triggers to it. There could be performance impacts. We probably just don't even want to get involved. Like it's not our system, it's not our data store. We just want to know what's happening in it. So we added this change data capture tool, which really what it does is it watches the change logs on the database and it creates these events from that. So we don't have to actually do anything with the database itself. We can watch this change log and insert our events as we see changes come through. And that helps us not have to deal with the people who are running the system that we're not part of, and that allows us to make sure performance stays at a maximum. So yeah, our initial load we knew was going to be millions of records. We're starting from scratch. We have this source system that's got all this data. I said earlier, we process 1 million claims a day, multiply that by like years and years and years of service, and you have just a ton of data. We didn't want a whole new process to do all that. So what we did was we created those synthetic events that we talked about earlier, and we basically scanned these tables, grabbed the keys, made them inserts, unprocessed, and we just created all of these synthetic events, and we were able to kick off just our normal process to do that initial load. So we didn't have to like write anything special. We didn't have to have any type of special operations happen. Once those events are in there, it will just start processing. So we went that route because we knew we had so much data we had to deal with, and that was the easiest way to do. So with all the data loaded and events being written by this CDC tool that we've added, we have an extremely fast and consistent data store that's able to aggregate data from any number of source systems. And this strategy has given our consuming applications the confidence to utilize our services when they've been using a legacy system that was comfortable for so many years.
Cool. Yeah, so some metrics that we have, like we said, we're using Apache Geode for its power of its response time. So those APIs, those microservices on top of that, we see an average of 15 to 20 milliseconds. They're very fast, they're very efficient, it's very good. We can see here that we're processing about 600,000 events per day at that near real-time state. So it's really flowing through the system. We have little to no problems with it. We talked about that initial load, right? We have all these records. How do we get in there first? We did a quick bench test. We saw that 60 million records we were able to process through in about 6 hours. Granted, it's a little more complicated than just converting an order to a customer order. We're talking about lots of information about members, addresses, things like that, and history there. So it's been really well for us. It's worked great for us. It's completely extensible. We were able to add new sources very easily, new business rule steps along the pipeline, along that stream, very easily.
All right, so that was what we had for you. We had 4 talks at this conference, and if you missed any of these, you should go back and watch them because they're all really good. We told a really epic story about becoming cloud native and how we did that with Geode and Spring. So please check them out online when they're available. Thank you.